Hi, everyone. Thanks for coming to our talk on overcoming observability woes as you scale your architecture. In this talk, we're going to talk about why scaling your service mesh observability is so hard, and we're going to talk about some of the things you can do to make it a little bit easier. We'll get started by introducing ourselves. So my name is Shane O'Donnell. I'm currently the team lead on the Gloo Mesh team here at solo.io.
And I'm Jahvon Dockery. I'm a software engineer on the Gloo Mesh team at solo.io.
So today, the plan is we're going to talk about service mesh observability benefits and challenges, reasons that you might use a service mesh and use it to enhance your observability suite, as well as some of the challenges that brings as you migrate from maybe a more simple microservices or maybe even monolith application. We're going to talk about some of the challenges as you outgrow a single mesh and have to start thinking about multi-cluster deployments. And then we're going to talk about some of the solutions we use for those challenges, specifically with Gloo Mesh 2.0, and how we can make all of this a little bit easier and a little bit more painless for your developers. Finally, we're going to talk about how important it is to have a single pane of glass, regardless of whether you have a single cluster or 100 clusters. You always want one place to come back to view the health and metrics of your service mesh. So I'm going to pass it over to Jahvon to talk about service mesh observability benefits and challenges.
Thank you, Shane. As you all probably know, observability as a whole may include things like logging, metrics, tracing, and even more. And oftentimes observability goes hand in hand with monitoring. For this specific presentation, we'll be focusing more on the monitoring and metrics side of observability. And first, I want to introduce you all to a method of monitoring called the RED method of monitoring. With this method of monitoring, it defines three key metrics: rate, error, and duration. You can think of rate as the number of requests you are serving, error as a percentage of requests that have failed, and then duration is the amount of time each request takes. The RED method of monitoring was popularized for microservices architecture. So the idea here is that you'll have these metrics for every one of your services, essentially. And with using a method like the RED method of monitoring, it really reduces the amount of service-specific knowledge that the team needs, because it creates a common language for the monitoring of your applications that you can use throughout your organization. And we'll be talking and focusing more on this specific type of monitoring. It will be mentioned throughout this presentation. For this presentation, we're also assuming that you made the jump to microservices already, and that you have already adopted a service mesh, or you're in the process of adopting service meshes. With service mesh, you pretty much unlock a lot of powerful features, especially for observability. And there are also some complexity and challenges that may come along with using a service mesh. So you may be wondering, as a user of service mesh, what could be next here? Before we get to that, let's talk about service mesh specifically. So another assumption we'll be using through this presentation is we're assuming that you are using Istio or related service mesh, which works by injecting an Envoy sidecar into each of your services. And I'll just get it started with just talking about some of the benefits of using Istio or related service meshes. So one big benefit is that it provides baseline RED statistics for every service via the sidecar that is injected into your services. It really removes the need for you to add any custom observability libraries into each of your services. And it also allows you to easily onboard new services with all of your observability suite, essentially based off of the injection that we have. In addition, Istio provides service-to-service communication with MTLS, and for each service, Istio provides an identity using the SPIFFE IDs. Another really good benefit here is that there's a single point of configuration for observability when using the service mesh. You'll still have to use third-party libraries, most likely like Prometheus or Grafana, to get the full observability benefits, but the nice thing about using the service mesh is you can define one configuration for all of your services, and then that is already propagated out to all of your services so that you can have like standardized monitoring metrics in place. On the flip side, there is an added layer of complexity because Istio and service mesh in general is a whole new technology to learn. So getting your team up to speed on this new technology and managing it can be a challenge. There are also new points of failures that you'll have to consider, such as the service mesh control plane encountering errors, or the sidecars being in a bad state, or even issues with the MTLS communication. I'm going to get us started by just thinking about and seeing how Istio specifically deals with the metrics flow through your service mesh. So in this diagram, you can see on the top, we have Istio-D and that's the control plane for the Istio service mesh. Essentially what you will do is you'll apply telemetry configuration within your cluster, and then Istio-D will take that configuration and use that when it's injecting your sidecars, and it will apply that to all of your services. And there are three different types of metrics that will be collected essentially. So the first type is a control plane metric. So those metrics are things that all deal with how Istio-D is performing. So that can include the number of known services and the number of failed injections. There's also proxy level metrics. And those metrics are metrics about the inbound and outbound traffic passing through the proxies. And then an example of that would be the number of requests with 503 response codes, for instance. And then the service level metrics are specifically metrics about the service communication. So with those metrics, you can see the number of requests sent from app A to app B. Metrics can be consumed by Prometheus deployment and visualized using Grafana. As I mentioned, those are additional add-ons you'll have to deploy. But one nice thing about Istio is that they also ship with the default set of Grafana dashboards. You can also configure tracing and access logs with Istio. Now that we talked about single cluster service meshes, we all know that they're great. But you may want to scale to the next phase, which is a multi-cluster service mesh. But I'll get us started by just talking about why we may want to scale to multi-cluster service mesh. So here I have a few examples. I'll just go through them. So the first example is you would like stronger tenancy borders within the service mesh. So you might not want teams to have access to specific resources or services. In order to resolve that, you split up teams into different clusters. Good example here is if you're at a healthcare organization, you may want to limit access to patient data. So you completely put that in one cluster and then give other teams access to different clusters where you have other services running. The next example is high availability. In this case, you'll be replicating your infrastructure across regions for fallbacks for high availability. You may also run into cases where you have your services spread out across multiple cloud providers. You may be using AWS and have some services there. You may have some services in GCP, or even on premises, and those all of those are all across different clusters. You also could run into a case where you want your application infrastructure to be closer to your users. So you'll want to replicate your infrastructure in different geographical areas so that your users have better performance on their end. Then the last example that we have is jurisdictional compliance and regulations may require specific isolation of the data and your services. So those data and services may have to reside in a specific place and may have to be separate from all of your other services. In terms of observability and the challenges that multi-cluster service mesh have with observability, there are three key points that I want to touch on here. So one point is that you'll have to deploy your observability systems into each of your clusters. So that's your Prometheus, your Grafana, those will have to live in each cluster separately. So the metrics collection and correlation is scoped to that single cluster, resulting in multiple data stores for that data. You're also losing context for cross-cluster traffic when you have multiple clusters. So your data needs to be stitched together for top-level analysis, and it's much harder to visualize the data, especially data regarding how different services are communicating with each other across clusters. And this cross-cluster communication also just creates some more operational overhead. Providing data visualizations is very difficult at the scale of multi-cluster, especially when you have hundreds of clusters. There are even more challenges outside of just the observability spectrum when you get to multi-cluster service mesh, such as security. But I'll just stop there in terms of what our challenges are here. But I do want to note that Istio has some features that attempt to make this better, such as Prometheus Federation. However, it's still pretty challenging since it adds an additional layer of complexity, as I mentioned. And now I'll pass it over to Shane so we can continue talking about multi-cluster scaling, but with the Gloo Mesh use case.
Thanks, Jahvon. So yeah, given some of these challenges, we wanted to take a look at which solutions we went with Gloo Mesh and how we solved some of them, and specifically why you might want to use something like Gloo Mesh over just a vanilla Istio when you get to that multi-cluster scale. So some of the biggest benefits you get are that you can abstract away the complexities of multi-cluster service mesh. As a developer, you don't need to worry about stitching together multiple Istio deployments, and that means not only metrics, but also networking. If you think about two different Istio instances, once a service communicates from one Istio to another across that cluster boundary, it's effectively from that Istio's perspective talking to an external application, and it's no different to calling a public API. But in reality, these service meshes are probably stitched together in a logical way where they're really just one global service mesh. So what we've done with Gloo Mesh is abstract away that complexity. So for the developer, it really feels like you're only working in a single cluster environment, but you get all of the benefits of multi-cluster. Another really strong point about this Gloo Mesh 2.0 architecture is that we built it from the ground up to support strong multi-tenancy guarantees. And this uses a concept called workspaces, which we're going to get into in a minute, but it really allows you to scale beyond not only just the scale in terms of requests per second, but also in terms of how many developers can realistically be working within your single service mesh in one organization. We also want to make sure that even as you scale across multiple clusters, that developers are able to have a single point of configuration. And this kind of comes back to that point of the amount of clusters that your application is running on should be at least somewhat abstracted away from you. You should be able to configure where everything goes in a single place and then just have your platform abstracted away and push all of the config exactly where it needs to go. And finally, you want to make sure you've got that single pane of glass. So you've got one place to view all of your observability metrics, regardless of which clusters it's coming from or how many clusters you even have in the first place. So to look at how we accomplish some of this, I'm going to take a step back and look at the Gloo Mesh architecture and kind of how some of this data flows. Now, I know there's a lot going on in this diagram, so I'm going to break it down. Here you can see we've got 5 clusters with a cross-section of our main 2 cluster types. And the core principle here is that we install an Gloo Mesh agent on each of what we call the workload clusters, which are clusters that are serving user request data. And then we also designate one cluster to be what we call the management cluster. The management cluster runs what we kind of consider a control plane of control planes. So you can imagine Istio is a control plane for Envoy, but Gloo Mesh is a control plane for Istio. And what we call this control plane of control planes is the management plane. In terms of how all this configuration works together and how that flows, so at the start of our flow, you can see the agent here in the bottom right is going to discover all of the things that are in its local cluster. So all of the Kubernetes services, all of the existing Istio resources, what Istio revisions you might have deployed, all this kind of thing. And it's going to send it back to the management cluster over a mutually encrypted TLS connection. Then essentially the management cluster is going to take all of this data that it's receiving from all of the clusters in your global service mesh, and it's going to run a translation loop to figure out, based on all of this data and based on all of the inputs that the users have created using Gloo Mesh API, which outputs we need to generate for every single output workload cluster. And the nice thing about this is there's a lot of nuance depending on where things live in specific clusters. So if you can imagine considering configuring something like a Istio ingress gateway, if that's got some routes to go to the local cluster, the cluster that the gateway is living in, and some routes to go to another cluster in your global service mesh, the way that routing works is going to be different from an Istio configuration perspective. Some of them will be able to just use that local kubedns, or it'll be able to route straight to the local services. But if it's going across cluster, you might need to set up things like destination rules and service entries in Istio. And this is one of those things as a developer, you don't want to have to worry about that, right? It's an implementation detail of Istio. So we've abstracted that away. So regardless of if you're in a single cluster or 100 clusters, the configuration should be the same in terms of Gloo Mesh resources. And we'll figure out all the nitty-gritty details in terms of what Istio needs to do. Finally, so after we've done this translation in the management plane, it pushes it all out to whatever Istio clusters need that translation, need those output Istio resources, and the local agent will just write those vanilla Istio resources, and Istio will send all of that configuration to the sidecars in that local service mesh. So I mentioned a second ago workspaces, and that's something that helps us scale quite a bit. So I just wanted to talk about workspaces a little bit. So what is a workspace? I just wanted to kind of define this term because it's a little vague. So at its core, a workspace is pretty much how we obtain multi-tenancy in an extremely large service mesh. It's really a logical partition that helps you kind of configure different configuration boundaries, and you can use it to divide responsibilities. And it's really going to depend on how your org and how your engineering teams are set up, but you can divide boundaries in multiple different ways. For example, it could be a specific team has ownership over a specific workspace, or it could be a specific application is siloed to a specific workspace. Or maybe depending on your organization, you might have a specific piece of infrastructure like an ingress gateway that deserves to be cordoned off into its own workspace, so you can have different settings just for that piece of infrastructure. But really, under all of this, at its core, all the workspaces from a developer perspective is a list of clusters and a list of namespaces within those clusters. And we kind of want this workspace paradigm to replace, as a developer, instead of you having to think about which clusters, which namespaces am I running in, you should just think about this is my workspace and everything's in there, and then all of the rest of it kind of fades away. So the same way that like Kubernetes makes containers be cattle instead of pets, we want to make clusters feel more like cattle instead of pets. So why would you use these workspaces? And I touched on a few of these points just a second ago, but essentially, just to give some examples, workspace isolation. So you can imagine maybe a billing team is working in a cluster that might also have a storefront app. And you don't want those two teams to be worried about stepping on each other, or if someone applies some kind of configuration. And I feel like this is the scenario that everyone's run into once you've reached scale with service mesh. You don't want one team to be able to apply some kind of accidentally overly broad configuration that shoots another team in the foot. So really what you can do is you can have admins set some smart defaults here, and because ultimately, if you think about it, your application teams probably don't care about some of this kind of DevOpsy stuff. They just want their applications to work. So you can have your admin team set some smart defaults that's going to work for everyone. And then you can have your application teams really focus on the thing that they're strong at, which is building applications. And again, it's important that all of this feels like a single cluster to that end user. We want to pretty much abstract away the multi-cluster abstract. We want to abstract away multi-cluster feelings so that you don't have all of that complexity, but you still get all of those benefits. Having said that, the reason you're going with service mesh is because you've got a lot of services that are running inside a single organization. And a lot of the time, these services are probably going to be useful in more than one context. So we really want to promote sharing services across the org. So even though everything is by default isolated to its own workspace, we allow users to explicitly pick individual resources and mark them as exported, which makes them publicly available within the service mesh to any other workspace. Or you can specify a subset of workspaces. So for example, you might have a notifications team that's working on a service for push notifications and a service for email notifications. And under the hood, that might be represented by 20 different microservices running in a local cluster. But as long as it exposes these two public-facing API services, any other team could consume them. And then on the flip side of that is something that kind of gets difficult, especially as you think of a very large org with maybe 100 clusters, which could potentially have hundreds, if not 1,000 engineers working on it. You don't want everyone to be reinventing the wheel for some of these boilerplate services. So we're kind of introducing this concept of cross-org discoverability. For all of these services that are exported and publicly usable across the service mesh, we're creating a service catalog so you can discover which services other teams have made available within your service mesh. So some of these shared services like notifications or billing or checkout or user profiles are available across teams. And that way teams can just expose the public interface while keeping the implementation details all private. So kind of looking at what that might look like as a concrete example. I know there's a lot going on in this diagram as well, but we can kind of take it slowly. So here we've got 3 clusters essentially, and you can see on the top left, we've got cluster 1, and the top right, we've got cluster 2, and then on the bottom, we've got a very large cluster for cluster 3. Within these clusters, you can see these kind of teal colored boxes, which represent workspaces. So you can see on the top left, we've got our API gateway workspace, and that's just confined to cluster 1. And the interesting thing about this is, like we mentioned earlier, because this is kind of a very critical piece of your infrastructure, we can cordon off your API gateway into a specific cluster, and maybe you have much more stringent security architecture or security posture for this cluster. Everything's going to be a lot more locked down, and specifically who's able to configure things and tweak things on this cluster can be a lot more strict than your other kind of more internal facing clusters. Cluster 2 is an interesting one because you can see here we've got our book info application workspace. But if you look at this blue line, you'll see it actually extends beyond cluster 1 and beyond cluster 2 and goes into cluster 3. So this workspace actually crosses cluster 2 and cluster 3. And importantly, like I mentioned before, to the developers working in this book info application workspace, the cluster boundary should be invisible. They shouldn't care which of these 2 clusters their application's running on. It all should just feel like a single cohesive unit to them. But you can also see in cluster 3, in addition to half of the book info application workspace, it's also housing the notifications workspace. So that could be a service that is exposes some kind of an API to send push notifications to our users. So how all of these things kind of interact with each other, there's some kind of just additional arrows drawn here so we can kind of like walk through it. But essentially, our bottom left workspace, which was our notifications workspace, is being exported. And you can see in our book info application, we're importing the notification service. So it's using that service from a different workspace. And then it's actually exporting to the API gateway workspace a route. So ultimately, this application, this book info application, is actually going to be exposed to the internet, and it's going to be accessible as a web application or a web page to end users, even though it's using some services from its own book info workspace and some services from the notifications workspace. Now, these are some of the API Gloo Mesh resources that are used for this, but we don't want to get too much into detail on this. It's a little bit too low level, but if you are interested in kind of knowing exactly how this works under the hood, I'd strongly recommend you check out Lynn and Scott's talk on the Gloo Mesh v2 API. They go into a lot more detail on how each of these individual CRDs works and how everything plays together. It's a really interesting talk. But bringing it back to observability, I'm going to pass it over to Jahvon to talk a little bit about how that works in Gloo Mesh specifically.
Thanks. So here you can see a very similar graph to what we were looking at earlier. So in the bottom, we have our mini workload clusters. And in terms of observability, within each of our workload clusters, we already mentioned that we have an agent deployed. Part of that agent's responsibilities is to serve as a metric server. So the sidecars for all of the services within your cluster, your workload cluster specifically, is pushing their metrics to their local Gloo Mesh agent. And then on the top side, our management cluster, we have our networking deployment. And then the networking deployment, we have, that's also served, the purpose that it's also serving is as a metric sink for Prometheus. And we also have a separate dashboard deployment, which I'll talk about in a bit. But essentially the way that we, Gloo Mesh really makes observability super powerful for multi-cluster service mesh is that we have our agents in all of our workload clusters forwarding metrics and access logs to the management cluster with an MTLS connection. The agents are also adding additional cluster-specific metadata to all of the data gathered. And then that data, once it gets into the management cluster, can then be queried by the Gloo Mesh dashboard and Prometheus that you install yourself. And it can be used to show some really powerful graphs. The dashboard specifically queries Prometheus and the Kube API to provide a single place for viewing all of the service mesh data. But you can also, as I mentioned, hook up Grafana for custom-made dashboards in the management cluster. And it will show you all the data for all of your workload clusters. And Shane will actually talk a little bit more about the Gloo Mesh dashboard now.
Absolutely, thanks, Jahvon. So when we talk about Gloo Mesh dashboard, we keep kind of coming back to this point of single pane of view glass. And now we're going to go through exactly what that means. And our dashboard actually is going to support multiple different user roles depending on what's important and how much access you have within this large global service mesh. So first, we're going to start off at the highest level, which is our kind of overview. And here you're essentially going to see a list of workspaces. And this is really for the service mesh super admin that has access to absolutely everything. And at that level, you might not care about individual services just yet. You might just want to see which teams are using a lot of requests per second, a lot of bandwidth, a lot of resources, which teams are maybe have an increased error rate or high latency. And it kind of comes back to some of those res statistics that Jahvon mentioned earlier. You want to be able to see all of this at a glance. So it's kind of like your check engine light. Is everything doing okay at the service mesh? Now, as an admin, you're able to drill down and you get a similar view to what you might get as a workspace admin. So a workspace admin is going to see something closer to this. And a workspace admin is someone who's in charge of running an individual specific workspace. So perhaps like a notifications team, as we were talking about in the earlier example. And really what kind of things you're looking for here is which other workspaces is your workspace interacting with? So which upstream dependencies do you have? Are you the book info workspace pulling things in from the notifications workspace? And then you can also see which workspaces you yourself are exporting services to. So who's consuming APIs that your own workspace exports? In addition to this, you kind of get access to that service catalog that I mentioned earlier. So services that maybe you're not yet using, but you get a list of here's some things that other folks within your service mesh are exporting that's available for other teams to use. And maybe you can use some of those to not reinvent the wheel and get better code reuse and make sure you're not rebuilding the same services over and over again and focusing on what really matters. So next up, we want to talk about this graph view. So our graph view is essentially a view of all of the mesh service relationships, all of the services within your mesh, regardless of which workspace they're running on, regardless of which cluster they're running on, and regardless of which namespace they're running on. We want to see an overview of all of these. Now, of course, this view is going to be tapered down to whatever logged in user has access to. So if you're a super admin, you might see a graph of just all of your workspace level things that you can drill into. If you're a workspace admin, you can see a graph of everything that you have access to and all of the exported resources that you're using. And if you're just a workspace developer, maybe you can only see some of the services that you're personally allowed to administer. But really what we're looking at here and some of the really strong value add over something like a vanilla Istio deployment is you can see here we've got some cross-cluster communications. So like Jahvon mentioned earlier, if you're doing this yourself with individual vanilla Istio deployments, the Prometheus server in each of these clusters kind of loses the context of that request as it crosses the cluster boundary. It just kind of thinks it's calling something outside the mesh and it doesn't really care beyond that. And then on the other side, it thinks it's your second service mesh is just going to think it's receiving a request and it doesn't really matter that it's from another mesh or it's from a public internet. It's all the same. Whereas Gloo Mesh specifically, because it has the context of every cluster and we stitch it all together for you, you can start getting really interesting statistics about intercluster communications, what's working, what's not working. And of course, all of these communications are also encrypted using MTLS. So you can see in this diagram, you see these little lock icons. So you can guarantee that these are all being encrypted end to end. You could also highlight if anything was not encrypted, you'd see like a red line here and an open lock icon. You can also see which services are using TCP and a bunch of other statistics you can drill down into. And of course, speaking of drilling down, you can mouse over any service just to get at a glance res statistics. So what's the throughput of any given service? What's the response time and how much of an error rate? If any of these numbers start creeping up a little bit, instead of these nice, pretty blue circles, you're going to start getting yellow for warning or red for errors. And it should be, again, pretty much immediately obvious to someone glancing at this. Is there anything wrong? Is there anything we need to investigate? And you should be able to drill down even further into any individual service to see where it's deployed, which clusters it's running on, which workspaces it's accessible from, and which are all of the policies that you've applied to it. But this is just kind of like your jumping in point to get that high level view. And again, we're kind of like focusing on the fact that this is a single application that from this place, from this UI, you're able to see every single cluster, and it's the same UI regardless of if you're running a single cluster or 100 clusters. It should all be accessible in one place, which is really, really powerful. So in summary, we've talked about how Gloo Mesh helps you enable large-scale multi-tenant service mesh. We've talked about how it lets you scale from a single cluster service mesh to 100 cluster service mesh and beyond that without changing the configuration that your own engineers and developers need to worry about. We've talked about how Gloo Mesh can help you monitor the service mesh health across all of your clusters. And we've talked about how it aggregates it all into a single pane of glass, so you get that one window to look through to see all of your service mesh health. So thanks for coming to our presentation. We're now going to be available to take any questions you might have in our live Q&A segment.